You cannot interchange 240-volt panels with 208-volt panels. The reason for this is that electrical panels are designed to operate within a specific voltage range, and using a panel outside of its designed range can lead to several problems. Firstly, using a 240-volt panel on a 208-volt system can result in the panel not functioning correctly. Electrical devices and appliances are designed to operate at a specific voltage, and if the voltage is too low, they may not work properly or may be damaged. The 240-volt panel's components might not activate correctly or efficiently at the lower 208-volt supply. Secondly, using a 208-volt panel on a 240-volt system can overload the panel. When a panel is overloaded, it can overheat and potentially cause a fire. The panel's components are rated for a specific maximum voltage, and exceeding that voltage can lead to insulation breakdown and component failure. Thirdly, interchanging panels can violate electrical codes and safety standards. Electrical codes are in place to ensure the safety of electrical systems and to prevent electrical hazards. Using the wrong type of panel can violate these codes and create a dangerous situation. Consider the design and functionality of electrical panels. An electrical panel, also known as a breaker panel or load center, serves as the central distribution point for electricity in a building. It receives power from the utility company and distributes it to various circuits throughout the building. The panel contains circuit breakers, which are safety devices that protect each circuit from overloads and short circuits. Circuit breakers are designed to trip or disconnect the circuit if the current exceeds a safe level. This prevents overheating and potential fires. Different voltage systems, such as 120/240 volts single-phase and 120/208 volts three-phase, require specific panel configurations and components. Residential electrical systems typically use a 120/240 volts single-phase system. In this system, the panel receives two 120-volt lines and a neutral line. The 120-volt lines can be used for standard household circuits, while the 240-volt is obtained by using both 120-volt lines for high-power appliances like electric ranges and dryers. Commercial buildings often use a 120/208 volts three-phase system. In this system, the panel receives three 120-volt lines that are 120 degrees out of phase with each other, plus a neutral line. The voltage between any two phase lines is 208 volts, and the voltage between any phase line and the neutral line is 120 volts. This system provides more power and is suitable for powering large equipment and machinery. The design differences between 240-volt and 208-volt panels lie in the busbar configuration, breaker compatibility, and voltage ratings of the components. Busbars are conductive strips inside the panel that distribute power to the circuit breakers. In a 240-volt panel, the busbars are typically arranged to accommodate two-pole breakers which connect to both 120-volt lines to provide 240 volts. In a 208-volt panel, the busbars are arranged to accommodate three-pole breakers which connect to all three 120-volt lines to provide 208 volts. Circuit breakers are designed to be compatible with specific panel types. Using the wrong type of breaker can damage the panel or the breaker and create a safety hazard. The voltage ratings of the components inside the panel, such as the busbars, breakers, and wiring, are also different for 240-volt and 208-volt panels. Using a 240-volt panel in a 208-volt system can cause the components to operate below their rated voltage, which can reduce their lifespan and efficiency. Conversely, using a 208-volt panel in a 240-volt system can cause the components to operate above their rated voltage, which can lead to overheating and failure. To determine the correct voltage panel for a specific application, consider the voltage requirements of the equipment being powered, the type of electrical system being used, and the applicable electrical codes and standards. Check the voltage rating of the equipment being powered to ensure that it matches the voltage of the electrical system. For example, if you are powering a 240-volt appliance, you will need a 240-volt panel. Determine the type of electrical system being used. As mentioned earlier, residential buildings typically use a 120/240 volt single-phase system, while commercial buildings often use a 120/208 volts three-phase system. Consult the applicable electrical codes and standards such as the National Electrical Code, or NEC, to ensure that the panel installation meets all safety requirements. The NEC provides detailed guidelines on the selection, installation, and wiring of electrical panels. Common problems that can arise from using the wrong voltage panel include equipment malfunction, overheating, electrical fires, and code violations. Equipment malfunction can occur if the voltage supplied to the equipment is too low or too high. Overheating can occur if the panel is overloaded or if the components are not rated for the voltage being used. Electrical fires can occur if the panel overheats or if there is a short circuit. Code violations can result in fines and penalties. To avoid these problems, always use the correct voltage panel for the specific application, and consult with a qualified electrician if you have any questions. It is crucial to consult the National Electrical Code, NEC, for guidance on panel selection and installation. The NEC provides comprehensive requirements for electrical installations, including panel types, ratings, and wiring methods. Some relevant NEC sections include Article 220, which covers branch circuit, feeder, and service calculations, Article 312, which covers cabinets, cutout boxes, and meter socket enclosures, and Article 408, which covers switchboards and panel boards. Article 220 provides the requirements for calculating the load on electrical systems, including branch circuits, feeders, and services. These calculations are essential for determining the appropriate size and type of panel needed for a specific application. Article 312 covers the installation of cabinets, cutout boxes, and meter socket enclosures, which are used to house electrical panels. This article provides requirements for the size, location, and protection of these enclosures. Article 408 covers the construction, installation, and wiring of switchboards and panel boards. This article provides detailed requirements for the selection, installation, and wiring of electrical panels, including the types of breakers, busbars, and other components that are permitted. It is important to note that electrical work can be dangerous, and it should only be performed by qualified and licensed electricians. Working with electricity can result in serious injury or death if proper precautions are not taken. Always energize the circuit before working on any electrical equipment, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work for you. In summary, interchanging 240-volt panels with 208-volt panels is not recommended due to the differences in voltage requirements, panel design, and safety considerations. Using the wrong type of panel can lead to equipment malfunction, overheating, electrical fires, and code violations. Always use the correct voltage panel for the specific application, and consult with a qualified electrician if you have any questions. Remember that electrical work can be dangerous and should only be performed by qualified professionals. Always adhere to the National Electrical Code and other applicable standards to ensure safety and compliance. For instance, suppose you have a commercial building with a 120/208 volts three-phase electrical system. You need to install a new panel to power some new equipment. The equipment requires 208 volts. In this case, you would need to use a 208-volt panel that is specifically designed for a 120/208 volts three-phase system. Using a 240-volt panel in this situation could damage the equipment or the panel and create a safety hazard. Conversely, suppose you have a residential building with a 120/240-volt single-phase electrical system. You need to replace an existing panel. The existing panel is a 240-volt panel. In this case, you would need to use another 240-volt panel that is specifically designed for a 120/240-volt single-phase system. Using a 208-volt panel in this situation could result in the equipment not working properly or being damaged. Always check the voltage requirements of the equipment and the type of electrical system being used before selecting a panel. If you are unsure, consult with a qualified electrician. Also consider the amperage rating of the panel. The amperage rating of a panel is the maximum amount of current that the panel can safely handle. The amperage rating of the panel must be greater than or equal to the total load of all the circuits connected to the panel. To calculate the total load of the circuits, add up the amperage ratings of all the circuit breakers in a panel. For example, if you have a panel with 1020 amp breakers, the total load of the circuits would be 200 amps. The panel must have an amperage rating of at least 200 amps. The panel short circuit current rating, also known as SCCR, is another important consideration. The SCCR is the maximum amount of fault current that the panel can safely withstand. The SCCR of a panel must be greater than or equal to the available fault current at the panel's location. The available fault current is the amount of current that would flow in a short circuit. The available fault current can be calculated by consulting with the utility company or a qualified electrician. It's important to select a panel with an SCCR that is high enough to safely withstand the available fault current. The panel's physical size and configuration must be suitable for the installation location. The panel must be large enough to accommodate all the circuit breakers that are needed. The panel must also be configured in a way that is compatible with the existing wiring. For example, if the existing wiring is run through conduit, the new panel must have knockouts that are compatible with the conduits. Consider the environment in which the panel will be installed. If the panel will be installed in a damp or corrosive environment, you will need to select a panel that is specifically designed for that environment. These panels are typically made of corrosion-resistant materials and have a sealed enclosure to protect the internal components from moisture. When selecting a panel, it is important to consider the future needs of the electrical system. Will you need to add more circuits in the future? If so, you should select a panel that has enough spare capacity to accommodate the additional circuits. It is also important to select a panel that is compatible with the type of equipment that you may need to power in the future. For example, if you may need to power a generator in the future, you should select a panel that is compatible with generator backfeed. Selecting the correct electrical panel is a crucial step in ensuring the safety and reliability of an electrical system. By considering all of the factors discussed above, you can select a panel that is well suited for the specific application and that will provide years of trouble-free service. Remember that it's always best to consult with a qualified electrician if you have any questions or concerns about selecting an electrical panel. They can assess the specific needs of your electrical system and recommend the best panel for your situation. Ignoring these factors could lead to dangerous situations.